Enthalpy cycles are a slightly strange application of Hess's law. Remember, Hess's law tells us that the path doesn't matter, but our beginning point, our reactants, and our end point, the products, is what matters when we're determining delta H reaction. So this is a problem that I found on an old IB exam, and it seems kind of messy, and well, it's messy, but it seems a little bit confusing. But these are the reactants for a given reaction, and these would be the products. And I can tell that because I could take one of two paths. I could either go this way to get there, or I could go that way and get to the same point. And the energy associated with each one of these paths is the same. So I know that this number combined with this number must equal this number combined with this number. Or more specifically, if I were to write it down here, actually I'm going to write it up here, that y when combined with negative 1301 must equal negative 788 minus 286. And then the question's asking me, what's the enthalpy of formation of C2H2 represented by the arrow y? So I want to know what this unknown is, y. So like I said, I can set up an expression there. Y when combined with negative 1301, or that clockwise path, must equal the counterclockwise path, the negative 788 combined with the negative 286. Solving for y, but not really, because this is assuming I don't have a calculator. Moving the 1301 to the other side, and now we want to see which one of these is consistent with that. And my answer to this problem would be A. Here's another way it can appear as an enthalpy cycle. There's nothing to solve for here, but once again, we can identify our two paths. This is one path, and I'll show it in blue. This is a different path. The total energy of one path must equal the total energy of the other path. So in this case, what's noted as delta H3 must equal the sum of delta H1 and delta H2. Here's a problem that shows up in your textbook. Rather than making up reactants and products, they use P and Q and R and S. So first thing I want to do is I want to identify my two paths. This is my starting point. That's my end point. So one option is to go this way. One option is to go that way. I know, again, that the sum of positive 50 minus 60 has to equal this unknown, or combining those, negative 10 equals x plus 30. X must equal negative 40. This path is negative 40. Now I'm going to take a look at my choices and see what makes sense. Which of the following statements are true? P to S equals negative 10. Well, if I went from here all the way to there, plus 50 minus 60, that is indeed true. R to Q equals positive 90. Going along here, positive 30. Going this way, the wrong direction would be positive 60 instead of negative 60. So positive 30 plus positive 60, indeed, that one is also true. P to R equals positive 20. P to R is from here to here. No, we had already figured out that that was negative 40. So for this one, that would not be true. My choices would be 1 and 2 as the correct answers. I have another one like this for you in your homework. They're a little weird, but they're not that difficult to do.